This is Baiju Vasudev and welcome to my channel pibyme Maths. Today we are going to continue with the remote learning series for Pure Mathematics 2. We are going to start with Chapter 1. In Part 1 video of Chapter 1, we covered 1.1 algebraic fractions and 1.2 dividing the polynomials. In 1.2 we learned about long division method, which is very important. Now today in this Part 2 video, we are going to cover 1.3 and 1.4, which are basically two theorems, the factor theorem and the remainder theorem. And we are left with 1.5 mathematical proof and 1.6 methods of proof. I'm planning to make a separate video for these two proofs. So let's jump into the factor theorem now. So what is the factor theorem? You need to understand what is the factor theorem very clearly. Let's say we take a number 105, let's say. We divide the number by 5. We are going to divide 105 by 5. So when you divide, 21 times 5 is 105. Your remainder is 0. You see, when you divide 105 by 5, your remainder is 0. When the remainder is 0, there is a special name for this divisor. We call it factor of 105. This 5 is a factor of 105. It's the same thing in factor theorem also. But factor theorem says in reverse order. For example, in algebraic terms, when you use algebraic expression or algebraic polynomials, when you divide a function f of x by, let's say, a divisor x plus a. When you divide a polynomial by x plus a and your remainder is 0, you apply long division method and your remainder is 0. Then this divisor is the factor of f of x. It's very simple, same like this, right? But that's not the factor theorem. The factor theorem says if x plus a, the a can be any real number. If x plus a is a factor of f of x, if x plus a is a factor of f of x, if x plus a is a factor of f of x, then f of minus a is 0. We are not going to apply long division method at all. If it is x plus a, replace x by minus a. If it is x minus a, take it as equal to 0, so x is a. Replace x by f of a. Or instead of x plus a, you have, let's say, ax plus b. If ax plus b is a factor of f of x, take ax plus b is 0, so x will be minus b over a. So in this case, if ax plus b is a factor of f of x, then f of minus b over a will be 0. That's the factor theorem. You need to learn this very clearly, and we are not going to apply long division method. So in your exam, when the question says use factor theorem to show that x plus a is a factor of f of x. Let's say instead of x plus a, you have x minus 3, let's say. X minus 3 is a factor of the given polynomial. When they mention use factor theorem, you're not supposed to use long division method. You just need to replace x by 3 here. So find f of 3. Find the value of f of 3. Replace all the x's in this function by this number 3. And if you get 0, that means x minus 3 is a factor of the given polynomial. If you don't get 0, that's not the factor. So this is the factor theorem. Now we are going to solve some problems from the textbook exercise based on the factor theorem. This question is taken from your textbook exercise 1C. Question number 1. Use the factor theorem to show that x plus 3 is a factor of 5x to the power 4 minus 45x square minus 6x minus 18. Okay, here in this question, x plus 3, they want you to show that x plus 3 is a factor of this. So here it's not mentioned use factor theorem, so you are allowed to use long division method. Divide this polynomial by x plus 3. If your remainder is 0, it has to be 0 because they say show that. You cannot say my remainder is not 0, so it's not a factor. That's wrong. So it is a factor already. You need to prove that it's a factor. But mostly you will have questions like use factor theorem to show that x plus 3 is a factor of this. When they say use factor theorem, don't ever apply long division method. We are going to use the factor theorem. Take the function as f of x. F of x is 5x to the power 4 minus 45x square minus 6x minus 80. And we are going to prove x plus 3 is a factor. If x plus 3 is a factor, take it as equal to 0. X is minus 3. Now replace x by minus 3 in the whole function. F of minus 3 will be 5 times minus 3 to the power 4. 45 minus 3 square minus 6 times minus 3 minus 80. So my answer is 0. It should be 0 because they already say show that if the question is verify whether x plus 3 is a factor, you might get 0 or some other value. If it is 0, say that x plus 3 is a factor. If it is not 0, just mention there x plus 3 is not a factor. But in this case, they say show that x plus 3 is a factor. So x plus 3 is a factor already. You just need to use factor theorem to prove that. So f of minus 3 is 0. Therefore, x plus 3 is a factor. That's it. So this is the factor theorem. And you can see here, though we learned long division method, and you might be thinking long division method is easy, right? Because when we apply long division method, we get remainder 0. So you can say x plus 3 is a factor. But here they want you to apply the factor theorem. Question number 14. Given that x minus 1 and 2x minus 1 are factors of px cube plus qx square plus 9x minus 2, find the value of p and the value of q. Here, you are given a polynomial and two factors of the polynomial. It's mentioned there already. X minus 1 and 2x minus 1 are the factors of this polynomial. So if you take the polynomial as f of x, px cube plus qx square plus 9x minus 2. If you take this polynomial as f of x, and if x minus 1 is a factor, then f of 1 should be 0. If x minus 1, replace x by 1. So if you replace x by 1 here, p times 1 cube, which is p, q times 1 square, 9 times 1, 9 minus 2 is 7 is 0. Or p plus q is minus 7. Take it as equation 1. Now you need to form another equation using the second factor. If 2x minus 1 is a factor, if you replace x by, take 2x minus 1 as 0, so x is 1 over 2. So if 2x minus 1 is a factor of this polynomial, then f of half will be 0 because x is half. So when you replace x by half here, p times half cube, which is 1 by 8, q times half square, plus 9 times half minus 2 is 0. So form another equation in terms of p and q, then solve simultaneous equation so you get the value of p and q. So what I'm going to do, I'm going to multiply throughout by 8. So p plus 2q equals, when I multiply by 8 here, 2 and 8 can be cancelled. You'll be left with 4. 4 9s are 36. 36 minus 16 is 20. 20 goes to the other side, minus 20. That's equation 2. So we got equation 1 and 2. I'm going to use my calculator to solve this simultaneous equation. So p equals 6 and q equals minus 30. That's it. That's how we apply the factor theorem to find the value of these two constants, P and Q. Question number 18. F of x equals 4x cubed plus 4x square minus 11x minus 6. Part A. Use the factor theorem to show that x plus 2 is a factor of f of x. Part B. Factorize f of x completely. Part C. Write down all the solutions of the equation 4x cubed plus 4x square minus 11x minus 6 equals 0. Here in first part, they want you to prove that x plus 2, using factor theorem to prove that x plus 2 is a factor of this function. If x plus 2 is a factor, your f of minus 2 should be 0. Don't put it as equal to 0 because that's what we are trying to prove. If you replace x by minus 2 here, minus 2 whole cube, 4 times minus 2 whole square, minus 11 times minus 2 minus 6, which is minus 2 whole cube is minus 8, 8 fours are 32, minus 32. Here 4 times 4, 16, plus 22 minus 6. So you get 38 here, minus 38 is 0. Therefore, x plus 2 is a factor. Therefore, x plus 2 is a factor because our answer is 0. So now we have in part A, we have proved x plus 2 is a factor of this function. In part B, they want you to factorize this function completely. So how do we factorize this function? When we learn long division method, we learn this very clearly, how to factorize a given function completely. Once you know this is a factor of this f of x, you are going to use long division method to factorize this function. So take the long division, apply the long division method. 4x cubed plus 4x square minus 11x minus 6. Divide this polynomial by the factor x plus 2. So the first term divided by the first term. 4x cubed divided by x is 4x squared. So you take the first term, divide by the first term, you get 4x squared. That will be your first term of the quotient. So take 4x squared and multiply both. 4x cubed plus 8x squared. Draw a line and invert the sign. So it's negative, this will be cancelled. 4 minus 8 is minus 4x squared. Bring down the next term. So repeat the process until you get the remainder as 0. Take the first term, divide by the first term. So you get minus 4x, you put minus 4x here. Take minus 4x and multiply both. Minus 4x square minus 8x. And change the sign. Minus and plus will be cancelled. Here negative 11x plus 8x is negative 3x. Bring down the next term. Negative 6. So if you multiply this by minus 3, you get minus 3x minus 6. When you change the sign, it will be cancelled. See. So if you are wondering why do we need to apply long division method here? Because we are trying to factorize the cubic function, given cubic polynomial. So once you know this is a factor of this function, you divide it using long division method, your remainder will be 0. So you can write this f of x as your factor or the divisor x plus 2 times the quotient 4x squared minus 4x minus 3. So we have factorized this polynomial into 2 factors now. Now they want you to factorize the function completely. That means this quadratic function has to be factorized again. So x plus 2. So I'm going to use my calculator to find the 2 factors of this quadratic function. One is 3 over 2. So it's 2x minus 3. Another one minus half. So it's 2x plus 1. So the very important thing, whenever you factorize a quadratic function, make sure you multiply the first 2 terms and verify. When you multiply these two, you get 4x square. Here also you have 4x square. That means these factors are correct. Because why I want you to do that? Sometime when the polynomial has a common factor. Let's say instead of this, you have 8x squared minus 8x minus 6. And when you factorize using your calculator, you will get these two same factor. 2x minus 3 into 2x plus 4. And when you multiply 2x times 2x, you get 4x square, not 8x square. Why this is happening? Because there is a common factor 2 for this quadratic function. When you take the common factor, you get this. So don't worry about it. When you multiply these two, you get 4x square. You don't get 8x square. So the 4x square should be multiplied by 2 in order to get this 8x square. So just put 2 in front if that's the case. But here, nothing to worry, because when you multiply both, you get 4x square. We have 4x square here also. That means our factors are correct. So this is the fully factorized form of f of x. Now the part 3 says, find all the roots of this function. So you need to put this factor separately equal to 0. So you get 3 roots. X is minus 2, 3 over 2, and minus half. Put them equal to 0 separately and find the x values. You got all the roots of the function. Now the next thing we are going to learn is the remainder theorem. There is a slight difference between the factor theorem and the remainder theorem. Let's say you are dividing a polynomial by x plus a. This may or may not be a factor of this function. The remainder will be f of minus a. That's the remainder theorem, that's all. When you divide f of x by x plus a, when you use long division method, you get the remainder, right? Instead of using long division method, you can straight away apply the remainder theorem to find the remainder. So just replace x by minus a, so you get the remainder straight away. So when the question says use remainder theorem to show that some number, real number, is the remainder of this function when it is divided by x plus a, you don't use long division method, use remainder theorem. Just replace x by the given number, you get the remainder. This question is taken from your textbook exercise 1D. Find the remainder when 4x cubed minus 5x squared plus 7x plus 1 is divided by x minus 2. Okay, here in this question, they want you to find the remainder using the remainder theorem. They want you to find the remainder of this function when it is divided by x minus 2. So the first step, take it as f of x. 4x cubed minus 5x squared plus 7x plus 1. And don't apply long division method because they want you to apply the remainder theorem. So replace x by positive 2. If it is minus 2, apply positive 2 here. F of 2 will be 4 times 2 cubed minus 5 times 2 squared plus 7 times 2 plus 1. So simplify and the answer will be your remainder. Don't expect it to be 0. It can be any real number. So 4 times 8, 2 cube is 8, 8 4s are 32, minus 4 5s are 20, plus 14, plus 1. So 32 minus 20 is 12, 12 plus 14, 26, 27. Even if you apply long division method, you can verify that when you apply long division method to divide this polynomial by x minus 2, you will get same 27 as your remainder. But here we are not supposed to use long division method because the question says very clearly use the remainder theorem to find the remainder. Question number 9. The expression 2x cubed minus x squared plus ax plus b gives a remainder of 14 when divided by x minus 2 and a remainder of minus 86 when divided by x plus 3. Find the value of a and the value of b. So in this question, it's given when the function is divided by x minus 2, the remainder is given already, 14. So use remainder theorem, take it as f of x. When the f of x is divided by x minus 2, replace x by 2. So your remainder is 14. It's given already. F of 2 is 14. So replace x by 2 here. 2 times 2 cube minus 2 square plus 2a plus b is 14. So try to frame an equation in terms of a and b. So you get 2a plus b is 2 cube is 8. 8 2s are 16. 16 minus 4 is 12. 12 goes to the other side. 14 minus 12 is 2. 8 2s are 16 minus 4 is 12. 12 goes to the other side. Minus 12 is 2. Take it as the equation 1. Now do the same thing for the second one also. When the function is divided by x plus 3, the remainder is minus 86. So replace f of x by minus 3. If it is plus 3, replace by minus 3. And the answer, the remainder is given already. So when you replace x by minus 3 here, 2 times minus 3 whole cube minus minus 3 whole square minus ax. So 3a plus b is minus 86. So frame another equation in terms of a and b and solve simultaneous equation. This is minus 27 times 2 minus 54. Minus 54, this is positive 9, negative 9. Minus 54 minus 9 is minus 63. Goes to the other side. Minus 86 plus 63. So it will be minus 23 if I'm not wrong. 3 cubed 27 minus 54 minus 9. Minus 63 goes here, positive 63. So it will be 23. We have two equations, solve simultaneous equation. So A is 5 and B is minus 8. So that's it. You don't need long division method or anything. Just use the remainder theorem to find the two missing constants, real numbers A and B. This question has been taken from the most recent October 2021 Pure Math 2 paper. Question number 4. F of x equals x square minus 2 times 2x minus 3 minus 21. Part A. State the value of the remainder when f of x is divided by 2x minus 3. Okay, this is another interesting question from the most recent paper, October 2021 paper. You are given a function in this form. And the first question is part A is, the question got only 1 mark. They want you to find the remainder of this function when it is divided by 2x minus 3. That's the question. So how to find the remainder of this function when it's divided by 2x minus 3? If you are thinking of expanding this and expanding and simplifying, then applying the remainder theorem, it's not wrong, but it's going to consume a lot of time and it's not worth 1 mark. So how do we find the remainder? Let me show you. Let's say you have 102 and you divide this by 5. So 25s are 100. Your remainder is 2, right? So you can write this 102 by, you can write the 102 as quotient times divisor plus the remainder. Quotient times divisor plus the remainder. So here, if you are given in this form, and if they ask you to find the remainder when 102 is divided by 5, you can straight away say this number is the remainder. The same goes here. When the function is divided by 2x minus 3, the remainder is just minus 20. You can straight away write this answer. So whenever you are given a function in this form, multiplication of two factors plus or minus another number here, the number here will be the remainder when the function is divided by either one of these factors. So if you go to my past paper videos, there is a playlist for P1 and P2 past papers. Look for these particular videos. And if you go to the question number 1, for example, Jan 2021, question number 1, the question is based on the chapter 1, factor theorem and the remainder theorem. And the question got 6 marks. So all this past paper question, you can go to all these past papers videos and take a look at these questions. I have put the question number also here. And when you look at it, you are getting an average of 6 marks from this topic. And it's an easy 6 marks if you learn the factor and remainder theorem and the long division method clearly. So you are given minimum of 5 marks here. I'm yet to make a video on the recent paper, October 2021 paper. October 2021 paper also got a question from this particular topic. So let's sum up the things we learned in our today's lesson. We started with the factor theorem. Factor theorem is if x minus a is a factor of f of x, if x minus a is a factor of f of x, then f of a will be 0. That's the factor theorem. So when the question says use factor theorem to show that x minus a is a factor of f of x, you just replace x by a and show that it is equal to 0. You're not supposed to use long division method. And then the remainder theorem. The remainder theorem says when f of x is divided by x minus a, the remainder will be f of a. It may or may not be 0. But when you replace x by a, you will get a real number here. The real number will be the remainder. And apart from this, there are a lot of questions in your textbook exercise. Try practice all the exam style questions. And you can go to my playlist for P1 and P2 past paper videos and try to look for the questions based on this topic.